Hi everybody, welcome to Tacoma, Washington. That's Kathy Troost, University of Washington. Today we study from the master old glacial deposits in the Puget lowland, right here at Tacoma Narrows Bridge. Thanks for joining us. Let's get started.
We're at a surface that hasn't been altered, hasn't been eroded through. This was built this way, and except for this little cut through for the trail,
Got it.
It hasn't been altered.
Yeah, so we're kind of up here on the flats, and underlying the flats is this Vashon Till.
Exactly.
Well, let's take a look. Let's see if it looks familiar. I was up at Yager Rock near Mansfield in eastern Washington. We were looking at some of the till there, and I suppose this is the same vintage here, roughly.
Yeah, so you know, we first have to convince ourselves that this is actually a till deposit, right? And so we're looking for this fine-grained matrix and rocks, pebbles, well, fine gravel, floating in this fine-grained matrix. That's what we're looking for. And then we're also looking for just how dense this is. This has been overridden by more than 3,500 feet of ice and compacted, right? It's not cemented. It's simply compacted. So unlike tills in the Midwest that are truly cemented with calcium carbonate, we don't have any cementation here.
3,500 feet
of
this far south, like we're close to the margin.
Let me correct, about 3,000.
Okay.
Yeah, about 3,000
Still
feet.
though, that's a lot.
That's a lot of ice. The Vashon ice sheet had a pretty steep snout.
Okay.
So underneath it, even this far south, there was still a lot of pressure being applied to the subsurface. Okay. So this is a pretty classic look.
Yeah.
This is a really classic look at the Vashon Till. We see little pockets. Well, it's a classic look for till in our region. Pockets where the gravels pluck out that indicate just how compact this material is. And then we also see these sort of fractures in here. They're probably a product of desiccation, drying out, which allows the till to sort of flake off or exfoliate when it's exposed.
So why couldn't this be a volcanic mud flow, let's
Exactly. So that's the other thing we have to evaluate is what depositional environment created this, right? And so we look at the rock types and the distribution of rock types in here.
Yeah.
And although we don't see it right here, but we're looking largely for pink granitic rock types that are sourced in British Columbia.
Oh, wow, really?
Yeah, there you go, your BC connection. If we were looking at a volcanic mud flow, we'd see largely volcanic rock types.
Yes.
And we don't see that here. So.
Plus the regional context, like you're finding this Vashon, it makes sense regionally, you know, literally all the way up to the Canadian border.
Yes, except.
Okay.
What's really cool.
Yeah.
And we'll see it later today, is we know, even though there's this huge trough out in front of us, it's the Tacoma Narrows channel of Puget Sound, that hasn't always been there during interglacial periods, and material makes its way all the way over here, including mud flows. We won't see mud flows today, volcanic mud flows, but we definitely see them in Tacoma.
So Kathy, just to kind of set the stage here, this is from one of your papers, I don't know.
Oh, I know the one. Okay.
Yeah, 2001. And so we are up here with your Vashon, and do you call it Vashon Till or Fraser?
Well, technically it's a Vashon Till of the Fraser glaciation, because the Fraser had more than one advance. Only the Vashon made it this far.
Only the Vashon?
Yeah. Okay. So we could call it Fraser and people would know what we're talking about, but yeah.
And what we're going to look at today is a bunch of older chapters that you have kind of compiled so beautifully. And I know this is 20 years old, but I've got your PhD from 2016 as well. And specifically,
Oh boy.
there's so full disclosure, I did an audio podcast yesterday and I sent it to Kathy, and she knows about these colors, and I'm on to this orange business, this possession till. So would you mind revealing right now how much of this sheet might we get a glimpse of, including interglacial beds?
Oh,
Kathy?
cool. Okay. Well, we're here at Vashon.
Yeah.
And at a distance, we'll see the Esperance sand, which is the advance.
Okay.
And we're at till, and we actually have another unit here on top of the till. It's the recessional outwash.
Oh, a little bit younger than the Vashon
Yeah,
till.
the stuff that looks a little more bedded there.
Oh, okay.
Same age, just, 10 years younger or something.
Oh, okay.
Right? Okay. So that's all we're going to see for the Vashon. Exposed down here are Olympia beds.
Good.
Interglaciation. We may see some chunks of it on the beach.
Okay.
I know there's possession here. It's way up in danger territory to get to.
Okay.
So you'll have to take my word for it.
I can do that.
Okay. We will see Whidbey formation.
Good.
Because we're seeing both of these, the glacial deposits that are on the bluff have to be possession.
Good.
Right? So we have to do a lot of process of elimination sometimes. We will see double bluff till.
Oh, God.
Yeah. And then we will see, and then you've got a mistake down here.
I love it.
Okay, so this Puyallup actually should be,
No problem.
Puyallup should be deeper.
Okay.
Well, it should be somewhere else.
Okay.
Defiance, MIS 8, is younger than the Puyallup.
Younger than the Puyallup.
Puyallup's about 1 million, I think. So we'll see evidence for 4
Wow.
glaciations here. And of course we know that there's a lot more. But these are the sort of the youngest ones of the bunch. So MIS 8, 6, 4, 2.
You know that there's a lot more than 4?
Yeah, and I'll show you.
It's such a thick PhD. I had to staple it in 2 parts, man. You were busy on this thing.
I am not going to tell you how long it took me to do this. Okay, hang on. Let me grab something else.
Good.
I really am not going to tell you that.
Okay.
I was working full time, Nick. It takes a while when you're working.
I know. And you didn't exactly do your PhD when you were 29
a baby.
either.
Yeah.
Right, yeah.
Okay.
Inspirational on many levels.
Okay. I've got 2 different images here. Okay. And the first one is the oxygen 18 ratio that tells us shows us climate cycles, right? So we have peaks to the left and peaks to the right. Mm-hmm. And when there are peaks to the left, the climate is colder. Okay. When there are peaks to the right, the climate is warmer. Yeah. And so if you look at this pattern, look at how many big peaks of cold there are. 1, 2, 3, maybe 4, 5, 6, 7, 8 within 1 million years. Then if we start looking older, so this is 2.4 million years.
Worldwide data, right?
This is worldwide data. Yeah. We don't have this kind of data for us here.
Right.
But if you look deeper, older, look at all these cycle fluctuations. Mm-hmm. And so, we've documented 1, 2, 3, 4 recently, and then in the previous workers have documented 1, 2, 3 others, but they don't really have very good constraint on the ages of those. But if you look at all these peaks, there have to have been more.
Yes.
I mean, let's put it this way, there probably were more.
Right.
And we don't know if we see them because we don't have ready, inexpensive access to dating.
Sure.
And it's hard to date stuff that's 1 million years old.
Well, that's what I love so much about your dissertation. Like you took all that previous work, summarized it the best you could, said, hey, we got some problems here. Like there's pretty casual use of some of these names.
Oh my gosh, that nomenclature problem. And I know that's one of the things you're trying to simplify or at least untangle is the
Yes.
nomenclature problem.
Ultimately, with getting to Eastern Washington, but we don't really have to do that today necessarily. But Brett's was here, and
Yes.
so Brett's was. Let me just try one thing with you quick, and then we'll move on. So Brett's and Willis were pretty clear on this Admiralty till as being the older till than the Vashon. Do you have any clear sense of what they were looking at when they were talking about Admiralty? Was it possession? Was it Double Bluff? Is it so long ago you don't remember?
It is pretty long ago, I don't remember.
Yeah.
I would actually have to go to their sort of type sections or where they described it and try to discern it. My recollection is it could have been any of those.
Okay.
Right, at different places. If they just saw a till below the landscape surface,
Yeah.
they would automatically assign it to Admiralty. And then more recent workers, that was what, 1913 or so.
Right.
And then in the 50s, they just started calling older tills the Salmon Springs. And so that was a misuse as well. So
Because the Salmon Springs is reverse paleomag, and we're down way older
down
than they thought.
Yeah, so if you look at here, Salmon Springs is down here at about 900,000 years ago. So really old.
Wow.
Yeah.
Okay, one more thing here, and then I promise we're moving on, because I don't want to. We're here to look at some beautiful outcrop and a beautiful setting, but this is also helpful at this stage, perhaps. Is it the same general message?
It's the same general message. It's I think it's a nice graphic that the Washington Geological Survey did.
Yes.
They took my, sort of messy one and simplified it, which is great. On the left side of the page, they list the glaciations that we know about. On the right side of the page, they list the interglaciations that we know about, that have been dated and named.
So why should I care about interglacials?
I love it. Well, you should care because I love them, right? And we're geologists.
Okay,
but,
that's my answer.
Okay. No, we care about them because these deposits, they look alike. And the way we can tell that we've gone from one glacial package into another is by finding these interglacial deposits.
I see.
There are marker beds, and we can recognize them. You'll see later why we can recognize them, but they tell us that we're getting deeper and deeper and deeper in time. So we have to use these to figure out these.
Because these individual glaciations have deposits that look very similar to each other.
They're indistinguishable, honestly.
Wow.
With a few exceptions. When you get down to this really old stuff, if the material has been exposed for a while, then you can see some pretty deep weathering lines on rocks. But up here in this section, if you were to hand me a block of it, I could not tell you what it is.
Even MIS 6.
Yes.
Pretty fresh
Even
looking.
MIS 8.
Wow, even the Defiance.
Yes. And what's interesting is the same thing happens here in these interglacials. You can hand me a chunk of Olympia, you can hand me a chunk of Whidbey, and I couldn't tell you which one it is without using some kind of dating technique. So I need to know the stratigraphic sequence, the context, as well as having some age control. Now this one, if you handed me a chunk of this, I could tell you because it's got a beautiful 2-foot thick reworked ash layer in it. So that one's really distinctive.
Ham Creek. And
Ham
the
Creek.
ashes from where, do we know?
Yes, but let me get back to you on that.
It's really old.
It's really old. Yeah, we found it in 3 locations, and argon dating gave us this age range.
Wow.
So.
So what's right around the corner?
Around the corner to the right, you could see the Tacoma Narrows Bridge.
Oh, good. Okay.
Yeah, so that gives you some placement. And that marker out there is for Point Evans.
Okay.
So it's a, sort of official term for where we are.
And so possession aged, orange pen.
Orange pen.
We don't have outcrop. This is up in the trees someplace. Is that the idea?
The possession is up in the trees.
Okay.
Because it's so hard to find,
Yeah.
I think that's why it went unrecognized down here for so long. It's not exposed as well here as it is up on Whidbey Island where Don Easterbrook did all of his work.
So why were you successful in finding the possession age till down here?
I was successful because I did geologic mapping down here. And that meant I came down trails like what we came down.
Yeah.
I walked all these beaches. I went back into landside headscarps looking for anything that would give me a clue of what the stratigraphy is. And the very best possession till outcrop is it's right across from us right here.
Okay.
There's a little tower,
Yeah.
single tower. Below that, that's a big landslide. And back in behind the trees, I came across this huge amount of water coming out of the landslide headscarp, a vertical face. And I went up to it, and it was perched on this big, thick till. And it's like, okay, well, what till is this?
Right.
Because I knew I had Vashon at the top.
Ah,
And so I set about trying to figure out what that was. And it required doing paleomag data. It required doing pollen data. It required a lot of radiocarbon dating. It required a lot to determine what it was. You can't date the till itself. We have to date stuff above and below it.
yeah. So that ended up being the main focus of your dissertation.
It ended up being the main focus because it was kind of new. It's like, what do we call these deposits? I knew that people were calling these deposits sometimes the wrong names because we just had very little information to go on.
So one of the big headlines from your work is that the penultimate ice sheet came almost as far south as the Vashon.
Exactly. It was just a little shy of the Vashon. And the bigger one yet here was, what's your MIS 6 color?
Blue.
Blue. The biggest one here was blue.
Biggest one was blue.
Next largest was the
Red.
Vashon,
Yeah.
red, and then the possession.
Okay.
Right. Yeah.
But all three advances got south of Tacoma.
South of Tacoma. Absolutely. Because we were
yeah.
able to find the till and document the age of it.
Yeah, we're going to walk our way along the bluff. Let me show you viewers what we came down. So this is just a little neighborhood trail. So one of the neighbors decided to make sure it was safe for folks to come down. So I don't know, maybe I shouldn't give this location away. I don't know, what do you think?
I don't think it's a problem. But,
Okay.
you'd have to give a GPS location for this parking spot, right?
Yeah, well, maybe I would. Maybe I would.
Hi there. Is that your backpack over there?
It is.
Oh, good. Good. Okay.
I figured it looked too like had stuff in it, so
Yeah. Yeah. Hi.
Hi, oh, look at that.
Look what you have. Really? Wow. Good job.
Very busy on a Sunday. Oh, my goodness.
I don't know, Nick, but I presume this came from up on top. This big cistern.
Yeah, so you've been teaching a long time applied geology at University of Washington, but you've also been a consultant for much of your career?
Yeah, I'd say it's just about half and half now between consulting and either teaching or mapping, I guess. Yeah.
And the consulting is almost always dealing with these Pleistocene deposits?
It is, it is when I work here in this area because we don't have that much bedrock exposed.
Oh,
Right.
right.
And dealing with the effects of the instabilities.
Yeah. It's all pretty soft stuff. I mean, you showed that till was compacted, but still, compared to bedrock, I mean, this.
The till is compacted until it gets really wet, and then it becomes mush because there's no cementation.
Yes.
Okay, so there's that. And then the intervening deposits, the stack here has variable degrees of apparent cementation.
Yeah.
Like the sand, because it doesn't have a lot of sill in it, isn't very stable, right? Even though it's been overridden as well. So
Well, let's go get our nose on some of this.
I want to put your nose down here
Good.
because
Get on all fours here. I love it.
yeah, so this is a fine grain deposit,
Oh, wow.
and yeah, it's pretty cool stuff.
Just thought it was bedrock, but it's not.
It's not, yeah, and it's been glacially overridden. So you see, it's kind of, I can just barely get my nail
Yeah.
into there. And the reason I can get it in so easily, even though it's not easy, is because this is wet. It's, you know,
Okay.
submerged part of the time. The important part about this one is that it has organic material in it. So here's, let me see if I can dig some out. Whenever we see fine-grained stuff, we look for evidence of organic matter because it might tell us that we're in an interglacial sequence, and that might help us figure out where we are in the stratigraphic section.
Okay.
This isn't in place. You know, it's come down the hill in a
Oh,
landslide.
Yeah.
But still, it's like it came down from up there somewhere. So it's important to, you know, pay attention to it and look at it. If we don't see any organic stuff in it, then we might suspect that it's a glacial lake deposit, and we get those when the ice advances and when the ice retreats. When the ice advances, it dams up whatever troughs are present at the time and deposits this fine-grained material in it. I'm not seeing anything right now. These are all, this is all modern organic worms. So the fact that I'm not seeing organic matter in here, my first speculation is that this is a what we call a glacial lacustrine,
Okay.
and it could be from the Vashon, could be from the Possession, could be from the Double Bluff. We don't know.
And you can't tell if you have a lake as the ice is advancing or retreating unless you see it all in context.
Unless we see it all in context, with one exception, and that's the recessional lake after the Vashon. It won't have been overridden by ice. So those deposits aren't as compacted as these, or consolidated.
It's fun.
Yeah.
Oh, summer's over, I guess. Look at these leaves. Holy cow.
So this is interesting here, Nick. There's this gravel of fine-grained stuff. We call it a clast.
Yeah.
And it's kind of like a rip-up clasts. So whatever the stream flowed over, it was picking up older fine-grained stuff, like that material we were looking at back on the beach.
Right.
So when you first look at this, if this were in place, one of the first things I do is look for evidence of glacial or interglacial origin. And so I stand back and I look for granitics, and then I also stand back and look for volcanics. And so here's a volcanic, I think, without cracking it open. So I'd look at that. And then because we're in the South Puget Sound, I would also look for ash layers and pumice, little pumice clasts that we tend to see more often in interglacial deposits. And you know, it would take a while to decide what we think this is. My instinct is telling me that it's glacial outwash, but I'd have to spend more time to really tell. I don't know where this came from up on the hill, so.
Okay, well, it's not in place, fine.
Yeah.
But I guess I'm slow on the uptake here, Kathy. Like, wouldn't the lithology of glacial stuff be the same as interglacial stuff?
That's a good question. So the glaciers that overrode this area came down from the Coast Ranges in British Columbia. And so they're carrying rock types from British Columbia that we don't have here. And so if we find those rock types in amongst the gravel, then we can say one of two things. Either it was derived in Canada and therefore carried down by the big ice sheets, or it has been reworked from those deposits. On the other hand, interglacial deposits accumulated as a result of rivers or lakes or sound, big troughs like this. And so for here where we are, the rivers coming out of the Cascades are carrying a lot of volcanic material.
Yeah.
So we look for those kinds of rock types in here.
Yeah, basically you're looking for rocks that are either Cascade origin or British Columbia origin.
Exactly.
Huh.
Exactly. And sometimes you get reworking and it's kind of hard to
Yeah.
know for sure. So.
Well, I don't think I can hold it. I think you've mentioned the word trough a few times, and I'm just curious what your thoughts are. Is there a way that you can just kind of comment briefly on these incredible troughs all through Puget Sound, and how were they created?
Well, this is clearly not my work. I just want to say that, right? Yeah. So Brett's even was theorizing about these troughs, and then most recently, this is PhD work by Derek Booth, and before him others. But the idea is that the ice sheet's coming down from Canada, and at the time that the last ice sheet came down, we did not have alpine glaciers intersecting it down here in the lowland. There was a bit of an offset in the timing of that. And so what that meant is all these big rivers starting up in Canada. What's the big river up in Canada, just south of Vancouver? Anyway, all the big rivers, right?
The Fraser.
The Fraser, the Skagit, the Stillaguamish. Yeah. All of those are still carrying water into the basin, and they pool up water along the edges of the ice sheet until there's more water than there is ice with respect to weight. The water works its way under the ice, coalesces under the ice, and is under incredible amount of hydrostatic pressure because we have this steep ice sheet. And so that pressurized water carves troughs under the ice. And this water that was under the ice exited down near the Black Hills near Olympia and carried a lot of sediment out with it, out the Chehalis onto the continental shelf. You can see a big wad of material out on the continental shelf that came from these troughs. So let me back up because this is an important part of the story. There's a seal out there. Sorry for the distraction.
Oh, that's good, right here.
They love hanging out in the Tacoma Narrows and playing in the currents. Now it's gone.
It just went under. Yeah. I think I got him. Yeah.
So imagine a glacier advancing today. We're in a warm climate. We're in an interglacial climate. We have these big deep troughs accumulating sediment. We have soils developing on the landscape. We have landslides, rivers creating terraces, etc. The ice advances south. As soon as it gets past the Strait of Juan de Fuca, it basically dams up this Puget Sound basin, and the water starts to fill up. The ice is advancing, and at the face of the ice, there's always melting and all these big outwash streams. And so sediment is getting deposited out into this lake, right? The fines get carried far. The coarse stuff gets deposited right at the ice front. But the ice continues to advance, right? And the lake continues to fill up until it reaches whatever the overflow valve is, just like on a bathtub, right? And that overflow is down at the Black Hills. At any rate, we get initially the deposition of fine-grained stuff like we were just looking at on the beach.
Yeah.
Ice gets closer, we get a little higher energy material accumulating, and it's the sand, like over here in the Bluff. The ice gets closer, and we start to get more gravel, heavier stuff. The ice gets closer and overrides and starts to deposit till. So if an ice sheet were to advance here today, the deposits would fill these troughs up to the top.
Wow.
Right? And then as the ice overrides it, it excavates these big deep troughs. And so the record here is incredible. So we have ridge, trough, ridge, trough, ridge, trough.
Yeah.
Right? We advance another ice sheet, we get this. they don't line up
They don't.
exactly in the same places. Not always. I think these big ones probably did, but we have evidence in the subsurface of really deep troughs filled up with, the fine-grained material and till, and it's pretty cool.
Okay, I'm going to push it probably too far now,
Uh-oh.
but there's a concept in eastern Washington that the coulees were not created with one main event, but it's you form a subtle coulee, then you have another generation and you're enlarging the coulee, and it's a culminating effect. Is there a weird correlation here that some of these troughs may be multiple like right here, this Tacoma, you call this Tacoma Narrows trough?
This is a Tacoma Narrows trough.
So as you understand it, the Tacoma Narrows trough is not just one filling and excavation. There might be multiple generations of carving to make these troughs.
I think that's true in some places, and
Yeah.
I'll tell you why. We'll see when we get over here.
Yeah.
Something called the Whidbey interglacial formation.
Okay.
And if you look at the cross beds in the sands,
Yeah.
it shows westward deposition.
Oh wow.
So it's coming from over there and across here.
Yeah.
And in places it's carrying a lot of volcanic rocks.
Huh.
So how would those volcanic rocks get transported across a trough like this
Right.
if they weren't in a big river system? And so we see that in many places. We see it on Whidbey Island the same way. The material coming out of the Skagit at some point flowed all the way across to the west side of Whidbey Island today. But now there's big, deep trough there in the way.
So that's a vote that the troughs are pretty young.
The troughs are pretty young. Now, that being said, maybe there was well, in Seattle, we know this.
Yeah.
The biggest part of Puget Sound up there by Seattle,
Yeah.
right down by the shores, we have Olympia age interglacial. So that's the interglacial just prior to the Vashon, right? And it's right down at sea level. And when we look at the deposits and interpret their depositional environment, we see that they're fluvial, right? And we see evidence of the vegetation growing down low where it wouldn't today, right? And so in some places, Puget Sound was probably a big river system that flowed to the north. And the flow indicators are northward deposition of those alluvial systems. How much of Puget Sound stayed in the same place? We don't know.
Well, I gotta tell you, my brain is smoking a little
I know,
bit
it's
because most of this I've heard glimpses of from your work and others, and I'm always just thinking about one time, the Vashon time, long younger than 20,000 or 29,000 years ago. And now I'm like, wait a minute, we got multiple chapters. How much carving, how many troughs were here before? That's where it really gets interesting to me.
It's really interesting, and it's important.
Yeah.
It's really important from understanding our history, but also if you start thinking about water resources,
Right.
right? If we could find deep troughs filled with this, we'd have beautiful aquifers.
Yeah.
But sometimes these aquifers are interrupted by big, deep troughs
Oh,
filled
right.
with silt and clay.
Right, silt and clay, got it.
Right. So,
Wow.
and because of water resources, because of deep drilling, that's how we know that these troughs have been carved and filled in many places.
Thank you for that detour. That was fun. I mean, ultimately, I have to say that I'm not trying to push Brett's too much on you because I it's so old, and I don't know how much of his work you remember from reading more than a decade ago, but ultimately, I'm just trying to see how much of his work here directly influenced his work a decade later over in Eastern Washington.
Well, there's a really cool outburst flood story over here, Nick. I don't know if you know about it. Over in Pierce County, right? And I'll show you an image in a little bit about it. But, he looked at that and recognized it for what it was. These are big flood grovels, right? So maybe you know, that was the precursor to him thinking about, you know, big deposits, big outburst floods and big scouring events, because that's what happened over here. And you can see it on the landscape.
And remember, he had all those chapters in his 1913 dissertation on different lakes, but he was really hammering a flood idea.
He also, right,
Huh.
because we think these were big subglacial lakes that burst through ice dams to carve these troughs on the surface.
He was saying that, or you were saying that, or both?
I think he was one of the initiators of that whole theory.
Wow, okay.
He and Bailey Willis
Yeah.
way back, yeah.
Huh. Oh, what a treat this is. Thank you. We're driving all the way down from Snohomish 2 days in a row. Man.
You know what it's like when you love what you're doing, right?
Yeah.
Yeah. All right, so we're getting ready to see some of our first of our older tills.
Oh, good.
Yeah.
Is that a separate island straight ahead to the north? Or whatever direction that is?
That's Vashon Island.
That's Vashon.
That's Vashon Island. Yeah. And across the water is a really cool community. You see those houses along the bottom?
Yeah.
That's called Salmon Beach.
Salmon Beach?
And if you pan across it,
Yeah.
you'll see a few gaps where houses don't exist anymore.
Okay.
And that's because they were knocked out by landslides that came off the bluff.
I'm with a consultant today. You're just seeing all sorts of prior jobs that you did, I suppose.
But you know, what's been really nice is because of that job, I got to go out in the field a lot and had to try to figure out what was going on. So it piqued my interest for sure.
Okay.
All right, we're getting close to seeing some good stuff.
This isn't Vashon. Come on, you kidding me? This is not Now, before today, I would have called this Vashon, right? I would have just assumed everything here was just thick, most recent glacial deposits, maybe interglacial, but I had no idea.
And a lot of people did do that. So that's why it's been fun to try to really figure out what's going on. This is a pretty nice view here. I think we get a little better one after we go around this vegetation. So I'll describe what we're seeing when we get around the corner.
Okay.
Okay.
How rare is this to have a sea cliff with this much exposure of this Pleistocene material?
It's the only one I know of from Seattle south.
Oh, wow.
This is a real keystone outcrop.
Oh, wow.
I did a measured section here because it's so unique to get so many different deposits and so many well-dated deposits. The next best places similar to this are up on Whidbey, on the south end of Whidbey Island.
No kidding.
Yeah.
What do you call this locality?
This is the Point Evans measured section.
Point Evans. Thank you.
Mm-hmm.
Oh, I notice you're wanting to get rid of those things, huh?
Yeah, they break down
Yeah.
and turn into microplastics. There we go. Okay, so feast your eyes.
Ooh!
Feast your eyes.
Hello. Hello. Oh boy. Oh my.
This is a complicated spot, but a good spot.
Good God.
Okay, so
I'm taking my pack off. We're going to be here a while. I think.
we probably will.
Excellent.
MIS 6.
Really?
Yes. I forget what color your MIS 6 is.
We're going blue, Kathy.
Okay.
We're going blue. Let me find that sheet. Okay, viewers. In case you haven't been keeping up with the audio podcast, this is my latest chicken scratch involving colors. Red is MIS2, Marine Isotope Stage 2, which has been hogging the headlines in Washington and beyond for good reason. It's the freshest. There's a lot of detail to be pulled out. But today with Kathy Troost, we are older. We're not looking at possession age, Marine Isotope Stage 4. It's here, but we can't see it. It's up in the trees. But by God, we are at some Stage 6 double bluff, glacial till, glacial outwash. Let's look at some detail with the expert. Wow, exciting.
All right, so I'm going to mess up your color scheme.
Oh, no,
for
that's
you.
good. That's good.
Okay, keep you sharp.
That's right.
To set the context.
Good.
All right, this is what I believe is present here, or what I fantasize at any rate, right? We started at the top, and we were in Vashon Till, right? This purple.
Yep.
We didn't see much of the advanced outwash or the advanced lake deposits.
Mm-hmm.
As we walked down the trail, we crossed over a lot of stuff, and now we're way down here. So we didn't see this whole bit of the section.
Oh, I got it. Okay.
That's up on the bluff.
Got it.
But up here is possession till and possession aged outwash. And then we have this thick sequence of Whidbey Formation interglacial deposits. And then we're down here in something that we've identified as the double bluff till, MIS6. So my purple is your blue.
Yep.
Right.
Yep.
Okay. So this is an older till, and it doesn't look exactly like the Vashon, but there's a couple of reasons. One is this is really wet.
Really wet.
It's perching water out of the hillside.
Okay.
And then it also gets wave splash on it, right?
Mm-hmm.
And so it's kind of discolored because of that.
Yeah.
But we still see these coarse and fine gravels in a fine-grained matrix, and we still see these molds left behind when you pluck the gravels out. And if we were to do what we call a point count and look at the rock types, we would find that this is BC-derived materials. And, you see rounded stuff, you see angular stuff. It's all within what we define as till. Now, I think this looks a little different than what we stopped and looked at earlier.
How so?
This has more coarse stuff.
Yeah.
And maybe just more gravel in general. But tills vary a lot over very short lateral distances. So we might have moved, 20 feet from that till outcrop up top in the Vashon and seen something that had more gravel in it. Or we might move 20 feet from here and see a facies of this that doesn't have as much gravel in it.
Can you paint us a specific picture under the ice about how this till is being deposited?
Oh, I wish I could.
Me too. I can't visualize it.
It's been the subject of a lot of debate, honestly. So I'm not going to do it justice, but I will say some people believe that there's this process of lodgement happening at the base of the ice, and that these things, all the sediment is entrained in the ice itself. That's how it got transported down here. And then as it's overriding the substrate, these things get smeared onto the substrate. So that's one lodgement theory. I think more popular, and I think more likely for us, is this idea of flow material, right? That the ice here is flowing down, and at the base of the ice, it's pretty wet. Well, we know it was really wet because we have all these big troughs to prove it.
Yes.
But that it was riding where it wasn't eroding, it was riding on a slurry of its material that's entrained in the ice. And so that slurry gets compacted as, so the ice lays it down, it overrides it, and it compacts it. And I think that's more likely here for several reasons. And it kind of helps to define this, you know, it's not water sorted, right?
It's not sorted, right?
It's
Just
not
at the
sorted.
most geology 101 level, we don't have layering of the stones. We have no organization by size or anything like that.
Right.
And with the interglacial deposits, which make up a considerable amount of stuff above us, things are sorted, things are layered.
Things are layered. You know, we saw that spot where things weren't in place anymore, but they
Yeah.
were still layered.
Right.
Water lane. This
Yeah.
is not water lane. This is a slurry. Now, the reason I think, you know, that there was a lot of water at the base is when you look right here, you start seeing a lot of deformation,
Right.
right? And so the ice is moving along. It's got this slurry underneath, and it's applying some pressure at the same time. And so it also can deform some of the layers and create these folds. It can create things that look like jelly rolls. It's just really
Oh
fascinating.
God, you're confident that this big backwards C is the ice itself?
It's from the ice itself.
Oh God, that's amazing.
Isn't that cool? So we call that glacial tectonic deformation, because this is still glacial stuff. And you look here, and it
Holy-
looks kind of like till and till up here. But,
Wow.
and this is pretty uniform in grain size right here. So imagine under the ice, we've got an uneven surface that the ice is flowing over. It's really wet.
Right.
And under the ice, we get little ponds. We get river valleys, and we get little ponds. And the ponds fill up with fine grained material. The ice continues to move, and it deforms the heck out of
Oh,
it.
that is amazing. This isn't common in deposits, is it? To have these
No. It's
glaciotectonic features?
you know, it is, well, how do I answer that? The people who've done the initial research on this are in Europe, and they see, you know, big deformation features.
Huh.
You can get folds, faults, all kinds of really cool features. And when we started mapping and looking at this stuff in detail, we started seeing more and more of this.
Really?
It's not very common here, but it's pretty cool when you see it. And what's important for us is we have to be able to say, is that tectonic? Is it landslide related, or is it glacial shoving?
Mm-hmm.
And this is so limited in extent that it's easy to say glacial shoving here. But you can get similar features in all those settings.
Glacial shoving. I mean, and more than 100,000 years ago too, if
What
we're
is
in
this?
MIS 6.
Yeah, this is 250. All right.
250,000?
I'm sorry, 150.
Okay.
Yeah, thank you for
Yeah.
straightening me out. Yeah, 150,000-year-old stuff.
Wow.
Yeah.
I mean, that looks as fresh as can be. If anything, I can imagine the ice just being here when looking at that as opposed to anything else, you
I
know?
know.
Oh man.
I know. And you know, if we were to
exciting.
dig back into here, we wouldn't see that it was weathered. And if this were to dry out, it would look just like the Vashon on top, except that, you know, there's a little more gravel in here. But there's parts of it that aren't very gravelly. So, yeah, it's a big puzzle, Nick. It's a big, exciting, challenging puzzle. As you know, because that's what you
Yeah.
try to solve all the time, right?
Well, I guess I'm pausing because I'm thinking about maybe changing my approach out in eastern Washington. If I ever do find some glacial till that Brett's was mapping that others say, nah, it's just flood deposit stuff. I was thinking that if I ever did find this older till in Spokane, it would look rusty and weathered, and here we are more than 100,000 years ago, and this stuff isn't clearly weathered or weathering rinds or anything.
No. Only, and the reason is for us. Now I don't know about where you are,
Right.
because this was buried,
Ah,
right? This was overridden and buried by subsequent glaciations, and it's only because of this trough that got carved during the Vashon that created these really steep-sided steep sides to the trough.
Yeah.
That after the ice evacuated, this stuff just started failing because it was too steep to stand up. and this stuff was exposed. So this was never really exposed for a long period of time. And so we don't get the deep weathering in it.
So is the deep weathering, like Steve Porter was talking about deep weathering over near Ellensburg,
Right.
is that less about age and more about lack of burial?
It's a combination of a lot of things.
Huh.
So this is hardly weathered,
Yeah.
right?
It's as fresh as can be.
It's as fresh as can be. If this were to stay exposed for a long period of time, thousands of years, it would start to weather.
Yeah.
But it's not, because we're here in a coastal environment. It's going to continue to erode and continue to expose fresh stuff. So
God.
it's about whether it's buried, and it's about whether or not the weathering processes are available at any one location,
Sure.
right?
Sure. Oh, this is a real thrill, especially if I'm looking at a bunch of granites that are from British Columbia.
Exactly. And look at how hard this stuff is, too, right? Now, there is a theory out there that the older deposits are harder than the younger ones, but we've not been able to test it.
See that?
So, I mean, maybe.
Wow. Oh, what a treat. What a treat. Is this your red granite you're talking
Yes,
about?
perfect. That's the pink granite from Canada. Exactly. Granitic. I don't know if the purists would call it a granite, but
Sure.
yeah. Great. Yeah. So we look for those. Those are our Rosetta Stones, right?
Red like a Canadian flag, huh?
Yeah.
Okay.
Yeah.
Oh, man. So let's try this real quick, Kathy, and then we can move on. So here's Brett's 1913. This is an original that Trevor Contreras gave me. Thank you, Trevor. And I just scanned every page of this frickin' thing because I couldn't find a good copy. And let me just read a little bit of Brett's and see if any of this sounds familiar to you or if you have any thoughts about this.
Okay.
So, Brett's in 1913. Admiralty Glacial, which might be Possession, might be Double Bluff, might be older.
Might be Salmon Springs, might be.
Okay. Good exposures of the till of the Admiralty glaciation, thank you, are rare, there being hardly a score in the many miles of sea cliffs of Puget Sound. Russell and Willis also found this Admiralty till. Nowhere deeply weathered. Its pebbles are for the most part firm, but decay has softened them in some cases. These variations in amount of weathering appear to have been determined by the thickness of cover over the till of any locale. You son of a gun. You just said that.
Look at this. These people knew what they were doing.
Yeah,
I'm just so impressed.
No estimate can be given of the thickness of the till sheet. The character of the surface over which Admiralty ice advanced is also unknown. A few exposures of deeply weathered glacial drift have been found, in which the decay of all but highly siliceous material far surpasses the alteration of the Admiralty till. Suspicion has arisen from discovery of these exposures that a drift older than Admiralty exists in Puget Sound. Admiralty till, however, has not been identified in the section above the supposed older drift. So if they've got deeply weathered glacial drift, it's probably not double.
It's probably not Double Bluff,
Yeah.
unless they happen to find a place where out of the influence of
Ah.
constant erosion, the till has weathered. And so when
Yeah.
you look at our really old things, the stuff that's older than 1 million years,
Yeah.
you do see more weathered clasts.
Got it.
Crucified clasts.
Got
right?
it. Yep.
And then when, I can't remember now who looked at the moraine of MIS 6 at the south, but that was one of the reasons they thought that was older as well, is because there was more of a weathering rind on the clast down there. But we don't see that up here. Our stuff is fresher.
And so it's possible to have weathering rinds at the very southern margin because you're not going to be buried by a bunch of stuff.
Exactly.
Huh.
Yeah.
Okay, I'm starting to get that. Let's do a couple more. He's got more on this Admiralty till.
Does he have a good location for some of it?
I think he does in a couple spots. Well, one is Denny Hill, which doesn't exist anymore.
No, but he would have been looking at possession there.
Yes.
They used to call that, and somebody subsequent to him called that the clinker till.
Oh, here we go. Here we go. Admiralty till generally unweathered in marked contrast with the overlying gravels. He's got gravels that are weathered. Are the gravels above us weathered?
Some of it is.
Okay.
Yeah.
Which are deeply stained almost everywhere. Overlying gravels. The till, in some exposures, a till which is thought to be Admiralty in age, which certainly is not a Vashon age, is considerably decayed, so much so that the pebbles may be carved with a knife blade like shale. This decayed till has been found in the cliffs along Port Washington Narrows. Port Washington?
Where's Port? I don't know.
I don't know where that is.
I don't know either.
In many exposures beneath the Vashon, about Little Rock.
Don't know Little Rock either.
Probably Admiralty age, but because of position near the surface. Okay, we've already got that.
We could look that up real quick on Google Maps.
Last one here. A till occurs in Red Bluff, near Ayers Point, Hood Canal.
Oh, okay.
In which decay has been more profound than that is shown elsewhere in Puget Sound.
Mm-hmm.
The extent of this decay exceeds that shown by the red gravels of the Chehalis Valley. Decayed granite pebbles retain the appearance of the parent rock. Okay, blah, blah, blah. I'm kind of putting you on the spot, but it's fun that he is finding this stuff that's clearly not Vashon. He knows that. He's just lumping everything into Admiralty, I guess.
I think so too. Just because at that time they didn't know
Right.
How many glaciations had impacted this area. So a couple of things sort of come from this. He talked about seeing some till on Hood Canal.
Yeah.
And how weathered it was. A lot of the till over in Hood Canal has basalt in it. And basalt weathers pretty quickly, right? And so even though I'm telling you we have to look for these pink granites here, when the till is, or when the ice is close to bedrock, it's going to incorporate local bedrock into the mix. And so in Hood Canal, in addition to finding some granites, we see some basalts.
So let's see basalt. That's crescent basalt over
They
there.
weather, exactly.
Oh, wow. Okay, so Brett's obviously was a great geologist, but he couldn't do what you've been able to do. And so what tools have you been using in your career that were unavailable to him so that you know these different stages in these different ages?
You know, I think accessibility is one, right? I mean, we can get anywhere we want to. Another is LIDAR, having the ability to read the geomorphology. That's huge. Then the advancements in geochronology, being able to use radiocarbon dating, being able to use argon, being able to use thermoluminescence, paleomag. I mean, all of those tools weren't available to him at the time. And on top of that, we can look into the subsurface with geophysical techniques, and people have drilled and collected samples, and we can interpret that, use the information that they find to help us put this whole story together. So when I look back at the stuff that Bailey Willis and Jay Harlan did out here, I'm blown away how right they were able to be. You know, now and then they mistook a volcanic mud flow for a till, But,
Right.
you know,
Right.
it's amazing how good a job they did.
What in the world?
What in the world is right?
What in the world?
Okay, so you see those big blocks up there in the Whidbey River deposits, and there are chunks of it down here on the beach.
Oh,
So look at these chunks, and you know what this stuff is.
it's Vashon.
Well, it's something, right? It's till.
It's still.
It's till, and it looks a lot like the Vashon till up on top,
It
didn't it?
does, yeah.
But these are blocks
Blocks of till within
within the
interglacial
Whidbey Formation.
Whidbey Formation.
So the Whidbey being what, 125,000 years old, this till has to be older.
It can't be Vashon, right?
Can't be Vashon.
The Vashon's way up high. These are blocks of till within the Whidbey. It has to be double bluff
Or
or
older.
older.
Yeah.
Because even where you've seen the Defiance till, it's unweathered.
Yes.
Wow.
Yes. And this, you know, this is dry. This looks a lot more like the Vashon that we saw up on top because it's dry. And
Yeah.
it doesn't look so much like the double bluff because it's dry.
'Cause it's dry.
And, you know, actually the gravel concentration is lower in these pieces
Yeah.
also, but that isn't a negative for it. It's like,
Oh, this has to be rare, doesn't it? To have huge rip-up blocks of till within this stuff?
this is the only place I know of it. And it's, to me, well, this whole story out here is very humbling. This is also very humbling because, you know, I come from a consulting background, and oftentimes we would drill until we hit till. You know where I'm going with this?
Yeah.
We would drill until we hit till because till's a great material for foundations.
Right.
So I love this as a lesson in, you know, going more than 1 foot into the till to determine where you are.
Well, you need a lot of energy to rip up that much till into these huge blocks.
Yeah, yes. Or something happened to create blocks, and a good analog is actually a landslide on Perkins Lane in Seattle. It's a really famous landslide, and it came out of a big face of till, and in the debris from the landslide, we could find Volkswagen bug-sized pieces of till laying on the beach from this landslide.
From the landslide.
So maybe somewhere nearby there's a slope back in Whidbey time that failed and the blocks rolled out into the river valley.
Okay, well, as a rook, just to close, that was the surprise, right? Okay, that's a pretty good surprise.
That's a pretty good one.
That's
Yeah.
a pretty good surprise. To close, kind of as a rookie here, the most simplest story in my mind is we have multiple advances of ice and we just keep dumping stuff down here. We just pile things up more and more as we dump more and more. I can't keep track of sea level and base level and things like that, but the most simple thing is we just keep, here comes another batch of stuff, just dump it in the place we dumped it the last time. There's no truth to that.
No, because if that happened, we would build up this really thick, tall stack of material.
Yeah.
And we don't. Look across. You've got this pretty flat surface over there, right?
Right.
And we call that the Boothian plane because it's something that Derek Booth first identified, even though he's still very much alive. So it's evidence of what he defined as the Great Lowland Fill. most of what you're seeing here, all across the Puget Lowland, is the top of the advance outwash from the last glaciation. And then there's a thin layer of till on that. But that's burying old topography. And when we look at the highest elevation on the old topography and we compare it to the highest elevation on the modern topography, it's pretty much the same.
Wow.
So there's a, I don't know what the term is, a mass balance effect happening where we only build up so high here, right? Because of the sea level, I'm not even sure what, but.
So, speak of some throwback, it's almost like a peanut plane idea that these guys were into 120 years ago.
Exactly, exactly.
Full circle.
My geomorphology professor was really into peanut planes. Victor Miller, he was just, yeah.
Oh, God.
I hope your mind's a little blown.
Oh, it's significantly blown.
Good,
Job well done.
good. Wow, and it's quiet out here all of a sudden. The tide is slowly dropping.
I brought a sandwich. You want to have a lunch?
Yeah, that sounds great.
You pick the spot.